All right, so a lot of these we did on Friday. We'll just go over them so that you're understanding what to do here. Reference angle, and the reference angle is the angle that exists between the terminating side and the x-axis. So what we're getting is a bow tie effect. Whether your triangle's in 1, 2, 3, or 4, your angle, your reference angle is this guy. It's a little acute angle. It's what's left over after you either subtract it from 180, add it to 180, do 360. And if you do it in radians, we can do it in radians as well. So if it's in degrees, you leave your answer in degrees. If it's in radians, you leave your answer in radians. And have you tried with the 5 pi over and the 10 pi over 5? Did you try doing it that way rather than having to convert it and convert it back? Try that. The pattern is nice. When you can find patterns in your math work, it makes life a lot easier. And you'll look for patterns throughout your life. You'll find patterns. This one, did we do this in class where we went around? Okay, we went around and around and then came back and was short right here. If you converted it to degrees and then converted back. If you converted it to degrees and you had your 60-degree angle, then your radian angle is 60 into 180. There's your 3. There's your pi over 3. Because it's got to be an acute angle. So it's pi over 3, pi over 6, pi over 4. And the other guy happened to be pi over 5 because you had a 36-degree angle, I think that was, 36. So, do you have questions on this part at all? Finding a reference angle? Aaron?
I'm talking about the radian.
Okay, so the radians. So say I gave you an angle, and I said this was, let's make it simple, 2 pi over 3. And I wanted to know what the reference angle is. So when you do this, take this bottom number. Because this is 0, this is pi, this is 2 pi. You just want to convert this to a denominator of 3. So therefore, this gives you 3 pi over 3. This doubles, gives you 6 pi over 3. So when you go like this, all the way around, you're looking for 2 pi over 3. So 2 pi comes right before 3, right? So it exists in this quadrant. So now you know where your quadrant is. This little reference angle is, take this guy and divide 180 by 3. It's a 60-degree angle. See it? So if you're looking for your 60-degree angle, and then you know your special triangle is your 60. From there, you set up all the parts of your 60-degree triangle. But if you're going to give it to me in radians, just say 60 goes into 180 3 times. It's got to match this bottom. It's got to match that bottom. Your reference angle is just that, pi over 3. You covered the 2. Your reference angle is that guy, pi over 3, because it's got to exist in quadrant 1. It technically all generates from here, and we just keep reflecting it all the way around. So that reference angle and that triangle have to be the same in each quadrant, right? If you get used to doing this, it's helpful. If not, you can convert this to degrees. Make it be your, this is your 120. So find out what quadrant's in, do the 180 minus 120, find out your reference angle, and convert it back. It's a little bit longer, but you can do that. Okay. This part, you had to find all 6 trig values. Now you have to find your missing piece. So Pythagorean's theorem gives us our missing piece. If this radical can be reduced, you have to reduce it. I would reduce it up front rather than reduce each one of them individually. But 65 cannot be reduced. If it's helpful, make your adjacent, your opposite, your hypotenuse. Make your information box right off of this. So if this is my angle of reference, opposite the 90 degrees is always the hypotenuse. Opposite my angle, and then adjacent. Fill them in. You found your opposite to be radical 65, and your hypotenuse to be 9. And you can find all your functions, take their reciprocals, to find the reciprocal functions. Can everybody do these? Off of a regular triangle? Anybody have trouble? No? Okay. regular triangle, you're measuring distance. It's always positive. It's when we put it on your axis that we have negatives and positives. Okay? All right. Okay.
Number 5, how did the 2 get dropped from the rack of 69?
How did the 2 get dropped?
Like it says 2 rack of 61 and then it says 61. Rack of 60.
Oh, very good. How did that get dropped? Let's
It was
see.
radical 224. I mean 244.
You can't, no, you can't,
Oh.
I didn't want to fog that up. If you get this, watch, 2 radical 61, you can set them all up using this. Like say I do my sign. My sign is opposite over hypotenuse. You have to reduce this.
Oh, okay.
So if you see that you can reduce it here, divide everybody by 2 and work off of this. It's much easier. And then you don't have to reduce each individual one. That's what I did there. Remember we kind of did one of those the other day? Like we had the 10, 12 triangle and we said you could reduce it to the 3, 4, 5. And so if you reduce it right off the bat, it's easier.
Oh, okay.
Yeah. Yes.
It's wrong if you don't reduce it.
It is. You have to always be reduced to lowest terms. Lowest terms. And do not pick up your calculators and give me a decimal if it's irrational. Okay, these, we're locating where your angle existed, where it resides. Take the XY point, find the missing part of your triangle, find all 6 pieces. This is where it comes into play, is X positive or negative? R is always positive. It's a radius. It's a directed distance. So when you locate your triangle, make an information box. See, here's another one that I reduced. If I worked with 12, 16, 20, I have to reduce them at the end. So if you reduce them here, then just use those pieces. I think we did one of these, like the 12, 10, 12, I'm remembering 10, 12, so 3, 4, 5. No, not at all. But if you do this and you say sine y over r and you leave this, then you will lose points. But then what I'm saying is each time you have to keep reducing this. Then you do the cosine, 12 over 20. Then you have to reduce it. And that's not a hard part. I mean, you can reduce it anywhere you like. I just figured if you reduce it up front, it's kind of a little shortcut. We did this one, I think. We located this point, because this is the point on your circle. It's not a unit circle. And we located in quadrant 3 that your x and your y are negative, your r is positive. Now, do you notice once we do your x, y, and your r's that we never say all students take chemistry, calculus, whatever you say? Because we already have your positives and negatives there. You don't have to worry about it. I always found when kids did this, so all students take chemistry, they were okay.
Miss Caduto taught us all strippers take cash.
Oh, yeah, Mr. Let me take this off a minute. Okay. All right, I didn't want to put that on the air there. Okay. All right, this part, I gave you one function, and I gave you whether another part was positive or negative, so you could locate where it is found. Now, if I just gave you secant, you would say, where is cosine, x value, positive? Here and here. But now, this kind of qualifies it. Out of these 2, which one has a negative tangent? If it's less than 0, it's negative. If it's greater than 0, it's positive. So out of these 2, where is tangent negative? Quadrant 4. So now we know where your angle is. So now we label. You can convert this to a cosine first, take its reciprocals, x over r. You can, in your head, flip it r over x, whichever you like to do. Set this up, which you have to remember, down here in quadrant 4, y is negative. We set up y is negative. And again, you don't have to rationalize your denominators. You do have to reduce, but you don't have to rationalize anymore. So that's kind of a nice thing. It really helps not rationalizing when you take its reciprocal. Because you always want to take the reciprocal before you rationalize, because otherwise you're re-rationalizing. So It just makes it a little bit easier. Cosine, where is cosine negative? Where is my x negative? Here and here. Out of both of these, where is my sine? Sine is my y. Y is positive up here. I'm looking at this guy. If you try to remember cosine, sine, x, y, it's going to help you see where you should be, where x is positive, where y is positive, x is negative. The only one that you have trouble with is the tangent. But remember, tangent is positive here and across it's positive. Negative here and across it's negative. So that's an easy way to remember tangent. So find your pieces, build up your box. Here's your information box. I find this to be really helpful. Build your information box. And then do all your pieces from here. Does it matter if my negative is in the numerator or the denominator or out front? No. Where you have a problem is this. If I give you this, okay. If I give you this, I have a tangent that's negative. What quadrant is tangent negative? 2 and 4. Out of 2 and 4, what quadrant is sine positive? The second. So here's my angle. Tangent is y over x. Y is 3, x is 4, and r is what? 5. So when I make my information box, r is 5. Which one is negative in quadrant 2, the x or the y? The x. So my x gets the negative, not my y. Do you see what happens? We just say it's negative, tangent is negative. But you have to remember, once you place it in the quadrant, you got to decide which one of those two made it become negative. In this case, the x made it become negative, not the y. But we can put the negative on the top, on the bottom, or out in front. A lot of times you see them like this. Out in front. You got to decide, once you place it down, which one becomes the negative. Got it? Yeah? No questions? Alright. This one, evaluate your functions without your calculator, which means without your calculator, you have a special right triangle. Again, how do I know what my reference angle is? What do I do to this guy, the denominator? Divide it into 180. So I have a reference angle of 60. This one also, divide that into 180. What was my reference angle? 60. Now, place this side 3 pi, 6 pi. As you come around, you pass the 3 pi, you stop short of your 6 pi, because you only have 5 pi. So you're in quadrant 4 with a 60-degree reference angle. Label the one you're comfortable with. You don't have to be the unit circle. You just have to be the one you're comfortable with. Again, your 30, 60, 90, easiest way. Opposite the smallest is 1. Opposite the largest is 2. If you add those together, you get 3. This guy has to be the radical because it can't be greater than your hypotenuse. It's an easy way to remember. So when you evaluate a trig function, you locate your angle, and then you find whatever trig function this asks you for. Just find your x, y, and r, and then say, which one did you want? Oh, you want the tangent. Oh, you want the secant. Oh, you want the cosecant. That's how you evaluate a trig function. Locate it in your axis, build your special triangle, and then find it. These guys with the calculator, because this is not a special triangle. It exists in quadrant 1, but all you got to do is say tangent 33. Make sure your mode is degrees. This one you have 2 choices. To get a secant, it's always 1 over cosine. You could leave it in radians and put this in. It will give you this answer. Or you can convert this to degrees, leave your calculator in degrees, and put that in a degree mode. Remember, a cosine And we're going to see that in the next unit. A cosine and a sine can never be greater than 1. Their values are between 0 and 1, or negative 0, or 0 and negative 1. But their reciprocals, therefore, can be greater than 1, will be greater than 1. And we're going to see that as soon as we start graphing these, starting maybe Wednesday. Nope, not Wednesday. I don't have you Wednesday. So, Thursday. We'll start graphing them on Thursday. Are you okay with these? Because definitely you have one on your test tomorrow.
Do we have one with the, like the 8 and 9?
Like the 8 and 9? Let me just go back there.
What's on the quiz?
No, I'm not telling you. It's going to be very similar to this review.
No, like just different.
You, that might be one of them. That might be close. Okay. Basically, you're just locating your quadrant and where they are, building your triangles, getting your x, y arcs. Find two values, and we talked about this. The reason we find 2 is because there's no other qualifier here. It says, where is cosine negative? Where is your x negative? Over here. You got 2 quadrants where x is negative. Therefore, 2 quadrants where cosine is negative. So build one triangle. That's this. I just unrationalized it, but radical 2 over 2 should automatically tell you 45. Okay? And if you can't, you can always do second cosine, figure out what it is from there. This is a 45-degree angle in here and here. Now, if I want it in degrees, set it up to 180 and 360. You are 45 degrees short of 180. 180 minus 45. If you use your graph, you don't have to remember, was I supposed to add, was I supposed to subtract? You'll have to notice you didn't hit 180. You stopped short, 45 degrees. There's your terminating side right here. The other angle starts here and terminates here. It goes 45 past 180. Remember, you only go to the 180, 360 because you're to the x-axis only, not the y. Think of the bow tie. I can't wear my bow tie this way. I wouldn't be able to put my head down. Think of me with a big red bow tie on. So then convert it to degrees. Take your 45, divide that into 180. That's your bottom number. So this is 4 pi, 8 pi. Your short one, your 3 pi. You're past that, 1 past 4 is 5 pi over 4. Are you catching on to that pattern? How many of you are catching that? Yeah, it really helps being able to do that. Otherwise, you have to convert it, which you can. You can take 135 and multiply it by pi over 180. An easy way is like this. Put this fraction in your calculator and just go math fractions, and it reduces it. So when this reduces down to this, you just stick your pi back on top. That works too when you're reducing, when you're using your formula. This guy, cosecant is the reciprocal of my sine. So if you wanted to, you could also do sine. Where is the y negative? Down here. So quadrants 3 and 4. And I set this up. My x, either y over r or r over y, whichever one you set up. Find your x, and you'll know that this is your 30-degree angle. God bless you. So 30 goes into 180 6 times. 6 pi over 6, 12 pi over 6. And in terms of 180, it's 180 plus 30. And this guy is short of the 360. 360 minus 30. The sketches, I find, are the best way to understand your trig. Make sense out of it. You've got a coordinate plane, and you're putting an angle on here, circling 360 degrees on your coordinate plane. Yes. How did I know 6 pi? Because I took, did you get 30 reference angle? Take 30 and divide it into 180. 6. The bottom number is 6. So we make the top be the same. We double it. Easiest way to do that. If you converted this, because watch. If you convert 30 to pi over 180, Just cross this out. You're still doing this. 30 goes into 180. Excuse me. And if you come around here, you're stopping 30 short. You got one less than 12, which gives us 11. Okay? Alright, and then I think we have your applications. Your surveyor is trying to determine the width of the river, and he walks downstream. He finds this angle right here. He calculates this, so you've got your opposite side that you're missing, and you know your adjacent side. So you're dealing with the tangent. Again, you can just cross multiply this. Now, if you used your calculator in radians before, make sure your calculator is back to degrees. If you use that other one, remember it said the secant of, and it had a radian measure? If you flipped your calculator to radians, you gotta go back to degrees. If you get a weird answer, like this obviously has to be bigger than this, because this is a 62-degree angle. This guy's a 28. The bigger the angle, the bigger the side opposite. So this one has to be larger than 125. If it didn't, or if it came out negative, or came out weird looking, you were probably in radians. Right? Or sometimes, when you cross multiply, another hint is just put the 125 in front of this in case you forget to close your parentheses. This one, there's an escalator. If it rises in length to a platform and makes a 30-degree angle with the ground. I guess here's your platform up on top. A 30-degree angle with the ground. Your escalators go sideways. They don't go straight up. That's your elevators. So your escalators go sideways. There's your hypotenuse. And they wanted to know the height between the floors here. So again, you're dealing with an opposite over a hypotenuse. And it has to be less than your hypotenuse. You can even at this point, did anybody find another way besides drawing this out? This is your 30, 60, 90 triangle. If this is 30, then this is doubled, right? So can I just take half of 152 and find my missing piece using my special right triangle? You could do that too. If you spot your special right triangle. This is 30, that has to be 60, because you're in a 30, 60, 90 triangle. Alright. And you can draw the whole thing out. And I think this is the last one. You might want to pay a little bit more attention to this one. Hint, Janice, hint.
This is going to be the exact same one as this one?
I'm not going to obviously put the exact same one.
You might.
No, no, but I'll put one similar. So you've got to do two things. You have to determine how far apart are the towns. From here to here is what I want. I have to find this triangle here, and then I can find this triangle here, and then don't I just have to subtract the two? So again, like we did this before, we said your angle of depression is the same as your angle of elevation. And how do I know which one is the 32 and the 36 if I get confused? If this is steeper, don't my eyes have to go up higher to be steeper? So that's got to be the larger angle. Now, I set this up, big triangle, little triangle. So I've got tangent, opposite over adjacent. I set them up. I have to solve for my x and my y. And then I'm going to take them and subtract them. And if you subtracted them and they came out negative, you just subtracted them the wrong way, right? Because it's got to come out positive. This distance has to be positive. Can everybody do this? Two triangles. Want to see the answer? Okay. I was just making sure everybody could set this up. So subtract them. Always come up with a plan. What is it I'm doing?
Well, I did mine differently.
What you got?
I got the same answer, I just did it differently.
Okay. How'd you do it?
Like, first I set up the tan 32, and I equaled it to 37,000, but I did like the regular formula where I put y underneath, and then 1.
Oh,
And
okay,
then
you
I
did
equaled
law of
it
sine.
with-
That's fine. You did law of sines, and that's fine.